Alright, good people, so this is section 1.4, multiplication of algebraic expressions. Now, one thing I wanted to remind you of is, of course, when you have questions, not if, but when you have questions, because everyone has questions when they're watching a video, I want you to write them down right there. I want you to bring at least one question to class. If you're not thinking, if you don't have any questions, then you're not really thinking. So I want you to be thinking, I want you to be proactively engaged, and when you come to something you don't understand, I want you to write it down right there. Also, I'm going to be giving an audio check at some point. In fact, right now, I think I'm just going to drop some personal information. Here we go. My favorite movies are The Lord of the Rings. So, good job having your audio on. Write that down. Mr. Bergman's favorite movies are The Lord of the Rings. Now, let's do the math. So check this out. We're multiplying algebraic expressions, and multiplying them is going to be very similar to what it looks like when you multiply, say, like, yellow, why is it always yellow? 321 times 12, right? Okay, so you could do 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Carry the 0. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is there, boom, you got it all. This should be what I do that because now you can see the structure of the multiplication is going to be, the handwriting is going to be exactly the same here. Now what I'm going to do just to save space is I'm going to take this xy and 2y and I'm going to rewrite it over here. Xy and 2y. And now we're going to multiply them just the same as we did before. It's like a 3-digit number times a 2-digit number. So when 2y times 3y is 6y squared. 2y times negative 2xy is negative 4xy squared. 2y times 3x squared y is 6x squared y squared. Now we're going to have a 0, just like you have in the 2- and 3-digit multiplication. You put a 0 there. And now we go with the xy's. Xy times 3y is 3xy squared. Xy times 2xy is going to be negative 2x squared y squared. And when I move this over a little bit, we get xy times the first term is going to be 3x cubed y squared. I want you to notice something, and that's that the like terms just happen to be in columns. Like terms, like terms, like terms, and that makes them easy to add if they're all in the same columns. So when you add this, you get 6y squared in black. You get negative 4 plus 3 is negative 1 minus 1xy squared. 6 plus negative 2 is positive 4x squared y squared. And 3x cubed y squared. That's the answer. That's it. Let's do that again here. Yowzers. Okay, so I'm going to rewrite this as 2p squared q minus pq plus q. We're going to multiply. Just like a 3-digit number times a 3-digit number, we'll have 3 rows. Q times 2q is 2q squared. Q times 2pq is 2pq squared. Q times p squared q is going to be p squared q squared. We need a 0, because now we're going to multiply negative pq times all 3 of the top terms. That gives us negative 2pq squared, negative 2p squared q squared and just moving it over a little bit. Negative p to the third q squared. Now we need 2 zeros for the last row. This is going to be positive 4. 2 times 2 is 4 p squared q squared. 2p squared q times 2pq is going to be 4 p to the third q squared. And the last terms is 2p squared q times p squared q is going to be 2p to the fourth q squared all over 2q squared. These two cancel. Remember, I'm going to color code these. As you can see, we've got like terms here, and so we can add them. 2 plus negative 2 is 0. Oops. 0, and then 1 plus negative 2 plus 4 is 3. P squared q squared. Four plus negative 1 is 3 p to the third q squared. And we've got 2p to the fourth q squared. This is our answer. You don't have to write the plus 0, but it's there. It doesn't hurt. Now that method always works. There are faster methods. So if you wanted to, you could write this as x squared minus 2 and multiply. What you'll notice is that you'll get 4 terms, and it is always the same 4 terms. Some people remember these 4 terms when you multiply 2 binomials together as FOIL. You take the first terms, that's first. This is going to be 2x to the third y. Outside terms, negative 4 negative 4 x y. Inside terms, 3x to the third. And last terms, negative 6x. Sometimes you can add them together, but I don't see any like terms, so that's just going to be our answer. 2x cubed y minus 4xy plus 3x to the third minus 6x. Let's FOIL again. First terms, we get 15x squared. First, outside terms, we get 9xy. Inside terms, we get negative 10xy. And last terms, we get negative 6y squared. No like terms to combine. Oh, wait a minute. Yes, there is. The inside 2 terms are like terms. Check it out. 9 plus negative 10 is negative 1. So we've got 15x squared minus 1xy minus 6y squared. Those internal, the outside and the inside terms cancel, and you get that, as often they will. Alright, let's FOIL these. The first terms, first are 2x times 3y, which is 6xy. Those are the first terms. Outside terms are going to be negative 2x times the square root of 2. Inside terms are going to be 3y square roots of 2. And then the last terms are going to be negative square root of 2 times negative square root of 2, which is going to be minus 2. No like terms to combine, so then this is our answer. in general, foiling looks like this: AC, AD, BC, BD. Alright, now we could FOIL this if you wanted to. In fact, we could just say that this is 4x minus 5y times itself twice. 4x minus 5y times itself. So when you FOIL this, you get 16x squared minus 20xy, again for the outside terms, and for the inside terms you get an additional minus 20xy, and then the last terms are plus 25y squared. But oh, and then we've got like terms here, so you can combine them and you get 16x squared minus 40xy plus 25y squared. Now, if you notice, it's just this term squared, this term squared, and then you could multiply the two of these terms together and double them. Double the product. You get negative 40xy. And it's like that every time you have a binomial squared, it'll look like this. The formula, the pattern, looks like this. You'll have, if you have two terms, A and B, and then you're adding them together, if there's addition in the middle, and you square them, then really you don't have to FOIL, you can just remember that it's A squared plus double the product plus B squared. And in fact, this is a formula that you have to have memorized. Very important. Some people might forget that middle term. They might just think that 2 plus 3 squared is going to be 2 squared plus 3 squared. Now, if this were multiplication, then yeah, you could do it. Like, we do know that, and it is true, that 2 times 3, let's go, 2 times 3 squared is, in fact, equal to 2 squared times 3 squared. So when you're multiplying, this is true. You can distribute the exponents to both the 3 and the 2. But if there's addition here, you can't distribute. What you have to do is you have to distribute the 2 to the A and the B, but you have to remember this middle term, and it's so important. This middle term makes all the difference in the world. Because you can see there it is. It always comes up. Let's do that again with a pattern. Okay, so here I've got a binomial, and the first term is A. A is going to equal 2y squared. The second term is going to be 6x squared y. So I know that if I see A plus B squared, then I can change that into A squared plus 2AB plus B squared. Now, what are A and B? I've written it right here, so just back substituting, we get 2y squared, that's A, squared, plus 2AB. What's A? It's 2y squared. What's B? Is 6x squared y, and plus B squared. B squared is 6x squared y. And now b squared would be that squared. Now, distributing and multiplying and simplifying, we get 4y to the 4th plus 2 times 2 times 6 is 24. 24x squared y to the 3rd plus 6 squared is 36. X to the 4th, y squared. That is the answer. Let's keep going. Now this is a slightly different, because you can see here we don't have the same binomial squared. They're almost identical. The only difference is this plus and minus. And if we were to FOIL this, the FOIL would look like this. We'd have 4x times 4x, which is 16x squared. That's the outside term. That's the first term. The outside terms would be 4x times negative 7, which is negative 28x. And then the inside terms would be positive 7, so it would be plus 28x. And then the last terms is 7 times negative 7, which is negative 49. Now the positive 28x and the negative 28x, they cancel. Remember, they're like terms. So we get, in the end, we get 16x squared minus 49. That is the answer. Now, we could have gotten the answer way faster if we just realized that there's a pattern going on. Every time you see two binomials that are conjugates, that means they have one is a sum and one is a difference. Two binomials where they're absolutely identical except you've got a plus here and a minus here. Then when you multiply those binomials, you get this squared minus this squared. And in fact, the formula, the pattern, looks like this. It's the product of sums and differences, or sometimes called the product of conjugates. So here it is. When you have a plus b times a minus b, then you don't have to FOIL. In fact, it's a lot faster to just say a squared minus b squared. It's a formula you've got to have memorized, and once you practice it a couple times, I hope you will have it memorized. So check this out. And the reason why it's so important to have memorized is because next section I'm going to ask you to do the same process backwards, and the only way you're going to be able to do it backwards is if you have the formula memorized. So let's memorize it now early, so that we can really use it next section. Here I see conjugates. I see two binomials that are identical except one is plus and one is minus. So we can just say that what I see is if a is 5x squared y and b is 2y, then really this expression is just going to be a plus b times a minus b. And the formula says that when you multiply those two together, what you really get is a squared minus b squared. What that means is we've got, back substituting, we've got 5x squared y squared minus 2y squared. And if you distribute the squareds, then you've got 25x to the fourth y squared minus 4y squared. And that's the answer. A lot faster to go using the formula. Plus, we've got to have it memorized by next section anyway. Let's keep going. So here I see a product of conjugates. Where one is addition. There are binomials that are exactly the same except one's addition and one is subtraction. So I'm recognizing the pattern. If a is just going to be 4y squared and b is going to be square roots of 3, then really what I have is a plus b times a minus b. And so therefore the formula says that when you FOIL these out, you really just get a squared minus b squared. That means we have 4y squared minus square roots of 3 squared. And when you get rid of the parentheses, you see you get 16 y to the fourth minus 3. And that is our answer. Next problem. It might be a little difficult to see that we have conjugates here, but I will say that if you consider all of this 2x plus 3, 2x plus 3 to be a, and b to be 5y, then you have a plus b and a minus b. When you FOIL them out, you get a squared minus b squared, which is just going to be 2x plus 3 squared minus 5y squared. Okay, so that second term is going to be easy enough. That's 25y squared. I shouldn't say easy enough. It's going to be easier than the first one. Minus 25y squared. And the first term, when you square them, you'll know that this is a squared plus 2ab plus b squared. So you could FOIL it if you want. This is 2x plus 3 times 2x plus 3. That's going to be 4x squared plus 6x, combining the like terms, you get 12x plus 9 minus 25y squared. Next problem. Alright, and it doesn't look like, well, this is kind of strange, but because it doesn't look like you have a product of conjugates, a product of two binomials that have the same thing as plus or minus. But if you rearrange the terms a little bit, you can see that we can make it look like we have the product of conjugates. 5t minus 2x to the third. All I'm doing is rearranging the terms so it fits our pattern. 5t plus 2x cubed y squared. Now, a is going to be 5t. b is going to be 2x cubed y squared. So now we have a minus b plus a times a plus b. And the formula says that this becomes a squared minus b squared, which is just going to be 5t squared minus 2x cubed y squared squared. Getting rid of the squareds, we get that's 25t squared minus 4x to the 6th, y to the 4th. This next pattern that I want to talk about, I'm not going to try and convince you that it's true. I'm just going to show you what it is because the video is getting kind of long, and it'd take a while to explain and show you. But I could if you wanted to. So here you can see you've got a binomial, and it's not squared anymore; it's cubed. So that's going to produce all of these terms. The coefficients go like this. The 1, 1, 3, 3, 1. What do I mean by that? I mean 1 of these, 3 of these, 3 of these, and 1. 1, 3, 3, 1. 1, 3, 3, 1. You've got a to the third, a squared, a, and then there's no a at all. There's no b at all. There's a b here, a b squared, and b cubed. So the a's are descending and the b's are ascending. And if you have a subtraction here, then all you have to make sure is you do this as well. Actually, this is wrong, because this formula here should be minus b cubed. Anyway, those are the formulas we have to have memorized, and after we use them a couple times and be intentional about trying to memorize them, then I hope they do get memorized. So check this out. X plus 1 to the third. If I'm going to do this, that means that A is going to be X and B is going to be 1. And if it's A plus B cubed, then the formula states that we're going to have A cubed plus 3A squared B plus 3AB squared plus B cubed. That's because I was able to write that down because I have the formula memorized, and I hope you get it memorized too soon, especially because next section I'm going to have to ask you to work this whole process backwards, and it's going to be impossible to do without the formula memorized. So let's memorize it by practicing and being intentional about trying to remember it as often as possible. Back substituting, A is X, B is 1. That means we get X cubed plus 3X squared times 1 plus 3x times 1 squared plus 1 cubed. Or just eliminating some of the ones, we get x cubed plus 3x squared plus 3x plus 1. There it is. Now this next one, I'm going to ask you to do some of it, or the last part of it, by yourself. So here we have, again, A is equal to X, B is equal to 1. The formula is, as we see it, is basically an A minus B cubed. Therefore, the formula that I have memorized, and I hope you get memorized too, is going to be A to the third minus 3A squared B plus 3AB squared minus B cubed. And I want you to substitute here the values for A and B and simplify, and you come up with the answer. Pause it, and when you're finished coming up with the answer, then move on. 15, last one, here we go. This is A is going to be T squared, B is going to be 3B, so what I see is an A minus B cubed, and the formula says that it's A cubed minus 3A squared B, that's ugly, plus 3AB squared, I've got terrible handwriting, minus B cubed. So back substituting, we get D squared cubed minus 3A squared, that's really T squared squared, times B, which is 3B, plus 3A, which is just T squared, times B squared, which is 3B squared. Squared. 3B squared minus B to the third, and not B, but it's actually going to be 3B cubed. When you simplify, you get T to the sixth minus 9T to the fourth B plus 9T squared, not 9, 27. And it's 27 because it's 3 times 3 squared. And we also have a B, 27T squared B minus 27B p cubed. That is the answer. Alright, good people, I'm just going to say that this video is long enough. We don't have to do number 16, but what you do need to do is I want you to start your assignment. Start assignment 1D, and I just want you to do the first problem. Let me know how you do, and bring your questions to class.